zone to like get it
We're good.
fast. Fast. Okay. All right.
Okay. All right. My name is Nadeira, and we are group 16. So our task is to prepare a contingency table and the shortcut Bayes' theorem because we have a patient that is positive for breast cancer using the mammogram and with a fairly low rate in the state of 1 case per 1,000 women annually. The sensitivity of the test is 92% and the specificity is 95%. I'm going to turn you over to Vincent, who's going to show you our contingency table.
Okay. So contingency table, I took a sample of 100,000, as you can see here, multiplied it by the incidence to get the number of people with the disease. Now to get the true positive, I multiplied the number of people with the disease by the sensitivity and got 92. To get the false negative, I just subtracted that number with 100 and got 8. Now to get the true negative number, I got the people without the disease, which is 99,900. And multiplied it by the specificity, which was 95%. And I got the number of 94,905. And finally, to get the false positive number, I just subtracted that number with the people without the disease and got 4,995. That's it.
So my name is Blane. I'm actually going to be talking about the positive predictive value. So as my colleague was just talking about, Vincent, the true positive, the false positive, the true positive, you already went ahead and calculated those, but the positive predictive value is the true positive divided by the false positive plus the true positive. So the true positive was 92, the false positive was 4,995, true positive was 92, so it was 92 over 5,800 or 5,087, sorry, ended up being 1.8% approximately.
Mm-hmm.
And now my colleague Krishna.
So I'll just discuss Bayes' theorem and calculation for this problem for it. So Bayes' theorem basically just gives us the probability of something happening given one other circumstance. So in this case, what we're looking at is basically the rate of the disease times sensitivity over the rate of disease times sensitivity plus rate of not having the disease times the false positive rate. So plugging in all the numbers that we already talked about before, we get the same number around 1.8%. So this is basically the percent of probability that this woman has of getting breast cancer, given what we already talked about before. That's it.